Continuing from our force earlier, we're going to talk about impulse and impulsive force. Now, for impulse is the change of momentum. We can see impulse in the form of formula Ft equals to mv minus mu, where F is your force, your T is your time. That's why for this formula, the unit is Newton second. For impulsive force, it is the rate of change of momentum. We can see this by shifting the T on the opposite side, and you have the unit of force here as Newton. Now, when do we see impulsive force? We see impulsive force when an object is experiencing a collision. Object hitting a surface. For example, let's just say you were playing catch with your friend. You throw a ball, and he catch the ball using his own hand. He tried to catch the ball using his own hand. Now, what happened is, if let's say the ball is moving with a high velocity, you're going to experience, or your friends are going to experience, a large force on the palm of the hand, and it's going to be painful. So that's why for baseball games, they have the baseball mitts. So what they do is this glove or mitts, they absorb the impact. How do they absorb the impact? Is by increasing the time of collision. Why is this so? Is because in impulsive force, we see that the force is inversely proportional to time. So when your time increases, the force decreases. So here, let's just say I'm giving a simple number. A ball is moving. Its mass is 1 kilogram. Speed is 1 meter per second square. You need to stop the ball. Means that here, this is supposed to be U. The final velocity must be 0. Now, the time of impact between the ball and whatever it is going to hit, or whatever is catching it, is only 1 second. Now, what happened here is that your impulsive force will be 0 minus 1 times 1 over 1. Just a rough number. You're going to have 1 Newton force. But what happened if, let's say, this wall is replaced with cardboard? Now, the time of impact is going to be increased drastically. So the time of impact here would be increased, let's just say, to 5 seconds. Okay, so what happened is, you're going to have the same formula, but you're going to have a different final value. So here, the force or the impulsive force would be roughly about 0.2 Newton. So by increasing the time of impact between two objects, or between an object and its obstacle, you can greatly reduce the impulsive force. You can greatly reduce the damage. That's why when we talked earlier about inertia, we talk about how our airbag system works. So in the airbag system, what it does is that during collision, it releases the airbag . What it does, it allows an increase of time of impact. between driver and the steering wheel. So this have greatly helped during accidents where it reduces the potential of getting a concussion or brain death. Okay, and kat sini. Right, now we're going to look at other applications of impulsive force. We have, for example, the cardboard for egg trays. So, in the cardboard of egg trays, what we see is that the cardboard is designed in a very hexagonal manner where you can place your egg in one, and on this side you have another cardboard where it will retain the egg. Now, what happened here is that this positioning or this structure of the cardboard allow for an increase of time of impact when transporting the eggs from one to another. One place to another. So what we can see here is that this design of the cardboard creates an air cushion between the two cardboard, and this will prevent the egg from experiencing stress that may lead to the breaking of the egg. So before the development of this design, what happened is that people tend to carry eggs inside a basket. Now, the issue with carrying eggs in a basket is similar as how when we have our inertia problem. All of these eggs have their own mass. They move around when you are moving. They are affected by inertia. So out of hundreds egg, what will happen is that you're gonna result to 20 to 30 eggs being broken. Why? It's because transporting in a basket will lead to impulsive force acting on each eggshell to be large. We also see impulsive force application to reduce the impulsive force for car. Inside the car, at the side of your door, we have steel beam. And what this does is that it creates a crumple zone along with the hood and boot during a collision. And this crumple zone increase the time of impact. So when we look at our car,